Our next speaker is Daniel Corcos from Northwestern University.
So today, what I'm going to do is I'm going to present the results of a clinical trial to you, and I'm going to show you that exercise improves the disease state of people with Parkinson's disease. It improves their Parkinsonism. I'm then going to show you that it improves their function. I'm also going to show you some data that progressive resistance exercise improves cognition in people with Parkinson's disease. And then at the end, I'm just going to talk for a couple of minutes about potential and speculative mechanisms that might underlie what exercise does for a neurodegenerative disease. So here we have the vicious circle of Parkinson's disease. So when you have Parkinson's disease, you have problems in gait, postural instability, fall. It's a disease which hits many parts of the system. So you also have depression, apathy, cognitive decline, constipation, sleep problems, fatigue. And this gives rise to a sedentary lifestyle and physical inactivity, which, as many of you know, is just not good. The important thing about this slide to focus on is this little line here. There is some argument that, in fact, it is the lack of activity which really almost increases the rate at which the disease goes at. So it is the opposite of being neuroprotective. So in neurodegenerative disease, we're after a neuroprotective agent. Some people have argued that the lack of activity actually does the exact opposite, and it makes the disease progress more quickly. So the sedentary lifestyle leads to complications and comorbidities, cardiovascular disease, osteoporosis, and ultimately mortality. So that you can understand the data that I'm going to present, I'm going to walk you through how a neurologist assesses a person with Parkinson's disease. And they use the Unified Parkinson's Disease Rating Scale. And they will assess speech, facial expression, tremor, and if you're extremely Parkinsonian, you'll have a score of about 108, and 0 means you're in great health. You also have activities of daily living, such as speech, swallowing, handwriting. They also assess intellectual impairment. And I also want you to note that they assess dyskinesia, fluctuations, and other complications. So the point here is that when you give medicine to people with Parkinson's disease, you induce dyskinesias. These are unwanted, abnormal, involuntary movements. And this is very, very bad for the patient. And one of the things that we'll be talking about at the conference is how exercise can potentially interact with medication, both beneficially and also in a negative way. So you can imagine if you're exercising and you increase your endogenous dopamine levels, that could actually cause more dyskinesias. Counterpoint to that would be if you exercise, increase endogenous dopamine, you may need to take less and less medication, which would ultimately be good for you. Just going to give you a very, very brief trip through neuroscience, just so you understand the rationale for the kind of exercises that I do. So this is a very, very simplified schematic of the Parkinson's disease brain circuitry. Parkinson's disease is caused by a reduction in dopaminergic neurons in substantia nigra pars compacta. And so what you see on this side, which is the Parkinsonian side, you have reduced input to the basal ganglia. This results in the subthalamic nucleus being excessively excitatory, which causes an increase in the inhibition from the internal segment of the globus pallidus to the thalamus. And so you can think of the globus pallidus as acting as a massive brake on frontal areas, motor cortex. And so at that point, it becomes very, very hard to move when you have this reduced activation of motor cortex. And one of the things we're working on are interventions to improve the drive to motor cortex. Now, many of you are going to tell me this is just exercise. And so we've known for 2,500 years ago. By the way, when I stand here and I look towards the back at Jerry Thomas and Glyn Roberts, I see a striking similarity, both in terms of wisdom and also facially. And so we know in our own academy we have heightened wisdom, but we knew 2,500 years ago that lack of activity destroys the good condition of every human being, while movement and methodical physical exercise save it and preserve it. But there is a lot about exercise we don't know. I mean, I was in awe of the lecture last night about just how far we're coming on in understanding the genetic basis. If you go to a physician and you ask them, what dose of exercise should I be giving to a patient with Parkinson's disease? They can't tell you. There are many forms of exercise, but what we're going to be doing over the next many years is to try to find the best exercise for neurodegenerative disease in terms of type and dose. So why study progressive resistance exercise? Well, I'm going to give you perhaps 3 reasons why I study progressive resistance exercise. The first, and this comes from the work of Neuroscience back in 1991, that age does influence muscle strength. And there's several points I want you to take away from the plot. So here we have maximum voluntary contraction. Here we have age. And you'll see it's fairly, it doesn't change very much. There's a little bit of variability. But up until about the age of 50, 60, most people stay fairly strong. And then what I want you to notice, there are 2 points to this plot which is important. On the one hand, some people into their 60s, 70s, 80s, and 90s, there's no change in strength. For other people, there is this precipitous reduction through sarcopenia and eventually death and mortality. Now, for those of you who are new members of the Academy, I want to give you some good news. I'm really here now talking to Michael Brown, for example. So the very young Michael is kind of fluctuating here in his kind of mid-40s, maybe early 40s, Michael. On a good day, I think you pass as a 40-year-old. Once you join the Academy, and you've only got to look at Carl and Howard, no yellow card yet, Howard, and many others. Once you join the Academy, you're on this straight line. You just stay strong. And if you don't believe me, try to take a golf club out of some of our senior golfing members. That grip, you will never get the golf club out of them. So for me, strength is important. I was very privileged and spent a year in London working with Professor John Rothwell, and we studied patients off drug. This is force, and here this is on drug. And what happens is that when you take a person with Parkinson's disease off their medication, they become weaker. They are well known now to become weak as a population of people. So if you have a disease in which people become weak, it would seem to make sense to use strength training to improve their strength. With considerable help from Dr. David Valancourt for the last 10, 15 years, I've been doing a lot of work on functional magnetic resonance imaging. And here we have data from the globus pallidus and the subthalamic nucleus, 2 key nuclei deep in the basal ganglia. And we asked people in the magnet to generate 5, 20, 40, 60% of their maximum voluntary contraction. And then we're interested in is whether the basal ganglia are active when you're generating large forces. And so you'll see that this is the target force level, and this is the percent signal change in the GPI, percent signal change in subthalamic nucleus. And you can see over here that you can see the globus pallidus is neatly laid out. This is bilateral and symmetrical. And so the point being, when you generate large forces, you are involving the nuclei in the basal ganglia, which basically underlie the disease. So one reason we use strength training is that we think we're activating the specific nuclei which are in fact damaged in Parkinson's disease. So for those of you who write grants, and everybody in the room I'm sure does, we have this wonderful term, knowledge gap. So the long-term therapeutic effect of exercise in Parkinson's disease is not known. So I designed a study to compare progressive resistance exercise to fitness counts, which is a non-progressive flexibility strengthening and balancing program. I did this study for 24 months. I wanted to show that you can get people into an exercise program and retain them for a long period of time. Our primary dependent measure was the UPDRS motor score in the practically defined off stage. Patients were randomized to either progressive resistance or fitness counts. Well, some of you don't come from America. Those of you from America, you, the taxpayer, you paid for a personal trainer at a local gym, and the personal trainer was instructed how to administer the program, and they were informed of the patient group assignment. Now, neither the personal trainer nor the patient was aware of the study hypothesis. It's very hard to blind people when they're taking part in exercise programs, but we've blinded everything else apart from the person taking part and the personal trainer. They worked out twice a week for 90 minutes per session. They were asked to do no other form of exercise. For 6 months, they had the personal trainer twice weekly, and for 7 to 24 months, they had the personal trainer once a week, and then the other time they were asked to work out on their own, and the personal trainer tracked what they'd been doing. We used 11 strengthening exercises, and we increased the resistance as tolerated. We exercised all major muscle groups, the axial muscles, and the upper and lower extremities. Fitness Counts is this little, you can get in this little booklet over here. It's a published booklet by Cianci. It's been updated recently. It does stretches, it's non-progressive strengthening, breathing and balance, but it's the same at each session, so the patients got bored doing it. Here is our patient flow. We screened 70, baseline tested 50, randomized 48. At the end of 24 months, we retained 20 people in the progressive resistance exercise group, and we retained 18 in the fitness counts. In terms of the baseline assessment, the individuals were 59 in the progressive resistance, close to 59 in fitness counts. Parkinson's disease is more prevalent in males than females. They'd had the disease for 6 years. Their Hoehn-Yahr score was 2.2, so their disease state was very similar. Their UPDRS scores were very similar, and their levodopa medication equivalent wasn't different. Now, we've known in the academy for more than 50 years how great exercise is for one. And so the problem is it's very hard to do exercise studies for a long period of time with a no exercise control group. I would argue we've probably reached the point that it's not ethical to do that. I think one can debate that, but we decided not to do that. The problem when you have a no exercise control group is you do not know the natural course of the disease in people of that disease stage. So what I'm showing you here is from the literature how much more Parkinsonian an average person would get over a 2-year period. So here we have 24 months. This is taken from a study published in the New England Journal of Medicine. People with Parkinson's disease get about 3 UPDRS points a year worse by just disease progression. So here is the UPDRS score for the fitness count. And this is the mean change from baseline in motor UPDRS. So at 6 months, these people got 5 to 6 points better, and then they came back. But the important thing is that after 2 years, they were 6 points better off than had they done no exercise at all. The group which did progressive resistance exercise made about the same change here. Now, this exceeds the minimally clinically important difference. In Parkinson's disease, the minimally clinically important difference is 5 points. Both groups exceeded at 6 months. And for those of you who study other diseases, you probably would agree that the biggest change you get when you study disease groups is anything versus nothing, because so many people are so deconditioned that just the idea of getting out of the house, interacting with people, walking around the gym, getting home, does a certain amount of good. But then you'll see that when you continue the progressive resistance program, so at 24 months, these people were still 7 points better off. And they were 13 points better off than what we would predict the natural disease progression would be doing. I'm going to go through several plots. On this side, the absolute values, and on this side is the difference. So I'm going to focus on the difference. So this is the peak isometric torque. All of you know from principles of specificity, if you do weight training, you should get stronger. And at the end of 24 months, the progressive resistance exercise group were 10 Newton meters stronger than the fitness counts group. And then this is the extensor torque, and they were about 8 Newton meters stronger. At the end of 24 months, the progressive resistance exercise group were moving about 100 degrees per second faster. So the speed is a measure of bradykinesia, and the strength training made this group about 25% faster. So these people who generally move slowly are now moving faster. In terms of physical performance, this is the change from baseline in the physical performance test score. There was no difference between the groups. Now, we were powered based on the Unified Parkinson's Disease Rating Scale. My guess is we wouldn't have had a difference even if we would have had a greater N. So in terms of getting change in function, there are very few good measures of physical function which don't have ceiling effects. But the bottom line here is that both exercise groups improved the physical function of the people with Parkinson's disease. I'm sorry this doesn't show up very well, but on part A, we have the digit span. Here we have the Stroop color interference, and this is the brief test of attention. The red line here is a control group of Parkinson individuals we just followed for 12 months to look at their cognition. And what you'll see here, there was no change in the digit span. It declined for the Stroop and it declined for the brief test of attention. And then if we look over here, this is the modified fitness counts and progressive resistance combined. There was no difference between our two treatments, but both treatments, individually and combined, improved all three measures of, if you like, cognition or executive function. This is the first study in Parkinson's disease to really have shown that progressive resistance exercise can actually benefit cognition. It's been shown for other populations in other studies, but this is the first time there's been shown a change in cognition. So in summary, I hope that I've shown you striking evidence that progressive resistance exercise is best for the disease state. We alter the symptoms of the disease. I've shown some neurophysiological measures of strength, speed. I didn't show you muscle activation, but it does change considerably. Exercise in general improves physical function and cognition. So one can speculate on mechanisms. And if NIH is kind to me on October the 23rd, 24th, in maybe 10 years, I'll have some answers for you. So at a systems level, for those who use functional magnetic resonance imaging, what we're hoping to show is increased activation in both cortical and subcortical areas. We want to really be able to show that progressive resistance exercise does modulate the same circuitry that all other treatment interventions target, and that's the basal ganglia circuitry that projects up to cortex. We're currently using transcranial magnetic stimulation to look at the balance between inhibition and excitation in the cortex. In people with Parkinson's disease, the motor cortex is excessively inhibitory, and we are hoping that that excess inhibition is reduced by progressive resistance exercise. And we're also going to be using resting state connectivity. The idea here is that at rest, the brain is talking to itself, and we want to see whether there are changes in the resting state brain activity of people who do progressive resistance exercise. I'm going to finish with a couple of slides from an area that I'm not at all knowledgeable in, but I just thought that since we're a diverse group, I just want to talk a little bit about molecular mechanisms of which I know nothing. So I'll give you that disclaimer. So there was a very important study, in my view, conducted by Kasulis and colleagues in Neuroscience in 2012. And they took 4 groups of Wistar rats, and they gave them an 8-week training session. They had a no exercise group. You can do that with rats. They had a sham control. They had an endurance group. And they also had a progressive resistance group. And what they find at the end of the study is the endurance group and the progressive resistance group do equally well in terms of spatial memory. Both groups improve their spatial memory to the same amount, okay? But the interesting thing at a molecular level is that the mechanisms by which they did this were different. And I think this is one of the long-term challenges of the future, is to understand the molecular substrates of the different programs we use. So over here, you will find that if you look for the aerobic, the endurance group, they had an increase in hippocampal TrkB protein expression. The resistance group didn't. In contrast, if you look over here for the resistance group, they had an increase in hippocampal PAKT protein expression. And so these were upregulated quite differently. And so if you go through the paper very carefully, what you'll learn that the potential mechanisms underlying the cognitive benefits of exercise, and if you're looking at hippocampal measures, that IGF-1 is upregulated in both, BDNF only for aerobic, PIGF-1R for aerobic and resistance, TrkB only for aerobic, for PAKT is only resistance, PCMK2 only for aerobic, synapsin is upregulated for both, and synaptophysin is upregulated for both. And one of the interesting questions is going to be, we know the CDC recommends that we do both progressive resistance and endurance. And so the question is whether they are additive in terms of the molecular pathways that are upregulated, or whether, in fact, they interact in a negative way. So there's lots of room for future research. So what I hope, you know this all better than I do. I think there's clear and overwhelming evidence that exercise is good for you, especially if you have central nervous system disease. As many of you know, I don't do the work. I just attend conferences and have a good time with you. The work is done by my colleagues, Dr. Robichaud, David Poon, Rafferty and Chin, Dr. Kamela, Dr. Lurgins, and Dr. Valancourt. I did notice when I was preparing the talk that Jill is from England and Carl is from England, and so I thought that I would leave you with a final word from an Englishman. This Englishman was a 3-time Prime Minister of England, and in the last century, even before the National Academy of Kinesiology, he told us the following: those who think they have not time for bodily exercise will sooner or later have to find time for illness, which is none of us. Thank you very much.